Thank you all for tuning in, or whatever it is we can call this. I'm Mike Tueller, and today I'm presenting on a tool that can search a set of Greek and Latin poetry for metrical patterns, with no limit to the number of lines in the search pattern. I've put a link at the bottom of the PowerPoint here where you can find a copy of this PowerPoint, as well as links to the search site itself, hylas.org, and some other sites that I'll mention in this presentation. So, first of all, what is this tool trying to do? It might help to start with Richard Thomas's 1986 taxonomy of allusions, or as he calls them, references. He briefly mentions the possibility of what he calls a technical reference, an allusion anchored not to wording or the like, but rather to, among other possibilities, a duplicated metrical pattern. But without wording to guide us, how would we find such an allusion? We would have to search by metrical criteria first. And that means, ideally, getting a computer to scan a whole lot of poetry. A brief example might show what I mean. These two are complete four-line epigrams. The latter of the two at the top is clearly focused on numbers, the number of Niobe's children. After all, it was a comparison of numbers that got Niobe in trouble in the first place. So it is curious, after Tosakis and Hosake and Arithmos, that Lollius Bassus never mentions the actual number. Perhaps we consider this a winking allusion by absence. Mentioning numbers is a way to get in trouble with the gods, so Bassus doesn't do so. However, there is a poem from a few centuries earlier that has exactly the same rhythm. Not the same word breaks, mind you, but the same rhythm, or as the ancients would say, the same numbers. This poem, too, is about the death of a child, though I hadn't gone looking for it on that basis, and for that matter, if that is your criterion, you have an awful lot of weeding out to do in Book 7 of the Greek anthology. I just searched for a poem with the same rhythm. And there I found Tessera Kai Deketin taking up the entire first half of the final pentameter and giving us the required number. Admittedly a number of years rather than of children, but still it's possible that this may have been an intentional allusion. To find it by any other means would be somewhere between tedious and impossible. So how does the program find a line's meter? As you all know, scansion is one of those things that is very simple until it's not. So the rules I put on screen here, which are well known to you all, I'm sure, are exactly the sort of instructions that are really easy to give to a computer. And in fact, I wrote the core functions to do this in just about an hour. This resulted in a clear scansion for about 75% of the lines in my test dataset. But its penetration wasn't any deeper than that because, of course, there's synesesis and corruption and elision, not to mention the fact that some syllables, far more in Latin than in Greek, aren't quite clear until you tell the program what their native vowel quantities are. That was a lot harder to code, and it got me well north of 90% coverage, usually around 98 or 99%, especially for Greek. But the problem was that any solution to the last 1% or so was going to break everything else, because those are the strange exceptions where you can find a very learned explanation somewhere, but it might be easier to just say that something is long or short where it shouldn't be. Ultimately, I changed the model entirely and dropped the idea of rules. My program is now almost entirely probabilistic. That means that a fairly large number of syllables are neither definitely long nor definitely short, but rather stand a certain percentage chance of being long or short, which is then forced into order by the overall metrical scheme. This means that the statistics of Greek and Latin poetry itself, a predictive model, dictate the results. It also means that at most points in the code, it is processing not just one line, but rather a set of possible lines, each with attached scores derived from the model, until it reaches a final top-scoring solution. I'll walk you through the steps. The program starts by reading in a line of poetry. This has just the text, with no tagging other than metadata to identify the line by author, work, and line number. The poem then supplies a couple of inputs, a dictionary giving vowel lengths and syllable divisions for some words, and then, for the great majority of words which aren't in the dictionary, some rules of thumb that give syllable divisions but supply only vowel lengths that can be securely deduced. Those combine to turn that line into a list of syllables with vowels marked to the extent it knows so far. Next comes the function that tries to determine what the chances are that any of these syllables might combine. A single subroutine looks at the possibility of synesesis, consonantalization, and elision. Each set of two adjoining syllables is recursively tested for the possibility of these three things, and when they meet the basic criteria, the chance of the combination is tagged with a value derived from the overall dataset statistics. Since many syllable combinations happen only sometimes, the program now has a number of different configurations of the line to process in parallel as it moves forward, each one tagged with a probability. Now the program predicts syllable length, again based on the statistics for each combination of vowel plus following consonants and spaces. While we might be used to some rules here, the truth is that a great many of those rules are broken, and the statistics know how likely that is to happen. Thus, we now have the line in even more configurations, as various syllables toggle between long and short. This gives us an overall long-short profile for each line, labeled with an overall probability from multiplying the various probabilities invoked so far. However, at this point, a number of lines are weeded out if they are not in the set of patterns allowed by the governing metrical scheme. Now, about 75% of the time for dactylic hexameters, one of those lines wins in a knockout. Only one pattern of longs and shorts offered by the line is within the set of allowable patterns. But if that doesn't happen, then the program chooses a scansion on points, taking the overall probability as a score and declaring a winner. Most of the time, the score is overwhelming even so, but when it is not, the statistics allow the program to choose one possible exceptional case over another. Finally, word breaks are put into the line. For most words, a space before and after counts as a break. For most of the rest of those words, we don't count one of those. These words are listed in the dictionary. For a small subset of words, more information is required. Is that hoi a proclitic article or an enclitic pronoun? For those cases, the code invokes some grammar-based rules, and yes, here must have some human intervention, simply because this program doesn't have any actual language processing. It doesn't know what depends on what, and can't label grammatical function on its own. This is the one part of the program where human tagging is required. I should admit, by the way, that the state of the scholarship on these appositives, as they're generally called, is not as settled as it really should be to do this well, even when working by hand, and it's worse in Latin than in Greek. But for the sake of time, I'll leave that issue there and just say that the program does, in my opinion, a pretty good job addressing a question that is actually quite tough. But your mileage will surely vary. So, although the code of the program does have to work around some surprisingly tricky problems, like figuring out exactly where every syllable boundary goes, the truth is that its core power doesn't lie in the code. It's the dataset from which it takes its statistics, which is the same dataset over which the user can search. At present, it includes dactylic hexameters and elegiac couplets from these authors, plus a few scattered others. I should mention that the predictive percentages taken from the dataset are not identical to the statistics of the dataset itself. This actually would be an ideal place to utilize some machine learning, which could reveal which authors in fact have more influence over the others, and for which periods various probabilities shift. I haven't done that, though I'm working up the next version of the tool to allow that to happen a little more easily. Instead, what I've done is just drawn from years of non-digital humanities and weighted Homer and Virgil more heavily than the others by a couple of orders of magnitude. Thus, the program takes the position that these two stand as quasi-exemplars for the other poets. I found that when I didn't do that, things often didn't come out quite right, but with that adjustment, everything just snapped into place. So, score 1 for human learning, I suppose. Now, the most obvious thing that this program does is allow you to search for metrical patterns. But it's also the case that on the back end, which the user doesn't see, I'm able to spill out statistical tables on almost everything, either on the entire dataset or on individual authors and works. With those statistics, one can compare authors' habits to one another, possibly finding new metrical rules. You could do this on the web version as well, though it would be more time-consuming. It's also quite easy to take statistical outliers and find out which lines are provoking them. Then you can find out the circumstances under which strange scansions take place. This is a good time to actually demonstrate the tool. You can find it at hylas.org. Since another search engine was already named Diogenes after probably the most famous ancient Greek searcher, I decided to name mine after a poetic search, of which I'm quite fond. When you get there, there's really only one button of consequence, the search button. This is basically there for future development. I'm hoping to bring some of the other capabilities online that are for now exclusively available on the back end. But for now, there's our button, and let's press it. We now need to tell it how many lines in a row we would like to search. The search I showed you earlier in this paper was for a pattern that covered 4 lines. For now, let's be simple. Let's just search 1 line and click Next. We can now choose what kind of line we want to search. Right now, only 2 searches are available for dactylic hexameter and elegiac pentameter, so-called. For now, let's click the dactylic hexameter. You may wonder, by the way, why only those 2 options are available. Well, I figured those would be the best place to start, and I was personally curious about the results we would get from them. But the truth is that the engine is not particularly optimized for these meters. It can search for any meter for which it's been provided a pattern. So why haven't I done other meters, like say iambic trimeter? Well, the biggest reason is because of the choice blocks that just unfolded below the radio buttons here. It's pretty easy to walk the user through creating a query for a dactylic meter. The dactylic hexameter has only 32 possible variations. But iambic trimeter has over 100, even in its stricter definitions, so that would entail a huge development of the interface. In any case, let's make some choices. For each of these 5 blocks, we can choose a dactyl or a spondy, or we could pick the third option, which says that we really don't care. For now, let's do the first search that I did when I created this engine. Let's look for lines that are metrically identical to the first line of the Iliad. So that's a meinen, aede, thea, pele, e adeo, achilleos, 2 dactyls and a spondy, followed by 2 dactyls and the inevitable final spondy. Now we have a screen where we can choose word breaks. This has mapped out the exact pattern we've just given it with 3rd and 6th foot spondies, and it's asking us about every syllable, whether we're interested in its word break conditions. Now we could do nothing on this screen. If we just click next, then it won't care about word breaks one way or the other. It will just search for the line that has identical rhythm with no other constraints. But for now, let's go ahead and tell it we want the line to have all its breaks in exactly the same places as Iliad 1-1. So as you can see, the drop-down menu after each syllable offers 3 choices. A blank, which means we won't care one way or the other, a comma, which means we want to require a word break, and a bridge mark, which means we won't allow a word break. So let's duplicate that first line, bridge, break, bridge, bridge, break, bridge, break, bridge, all in 4 are bridges. 5, break, bridge, 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 and then the final break. Now we can choose what texts we want to search. As you can see, I've put in here a series of expandable menus that I hope make some kind of sense. You can search everything, all of a certain language, or just choose by authors and works. I'd like to select everything, so I'll just click all, and then next. Now, as you can see here, just 5 lines come up. The first one is the first line of the Iliad itself. The next 2 from Homer and Hesiod seem unlikely to be imitations. The 4th line is Pygri's quotation of the line. That's easy enough to discover without this tool. That leaves just 1 line from the Greek anthology. This is also the first line of a poem by Leo VI Philosophus, the Byzantine emperor of the late 9th and early 10th centuries. The poem's no epic. It's technically an epigram, though at 13 hexameters it's a bit long for one. As you can see, this line too constructs one of its bridges with an enclitic, but those are the rules of the game. Is this an intentional imitation? Hard to say, but if you read the poem, you'll notice that it presents an intriguing possibility. Leo spends the first two lines of the poem talking about how Epicurus has inspired him not to seek for wealth or time. He doesn't mention Achilles, but that name might come to mind. Leo then goes on to reject the temptations of Circe, the Lotus Eaters, and the Sirens. He thus replies to the Odyssey explicitly after, it appears, replying to the Iliad implicitly. In short, this is exactly the sort of discovery this tool was designed for. I'd do more, but you get the idea, and my time is limited. Feel free to try it on your own. As you might be aware, there are some similar projects out there. How does Hylas compare to those? Well, there are a number of projects, and I'm not going to claim that I even know about them all, but let's look at what I do know. First, a quick list. If you want more details on these, including links, again, my blog is the place to look. I'm not going to spend a lot of time on the first 2 of these. While their approaches are somewhat different, each is more on the order of a proof of concept than a working engine. These are rules-based tools, and they found, just as I have, that you can make a lot of headway, but you can't reach 100% coverage on that foundation. As far as I can tell, they are also made without dictionaries, which is one reason why it's good they work exclusively in Greek, the orthography of which gives enough clues you can get pretty far without one. Chiron, a project headed by Daniele Fusi at Ca' Foscari in Venice, is, as far as I can see, the most promising of these tools. Fusi is at work on what should probably best be described as an ecosystem of modules for working with text, including text editing and digital publishing. But what I'm concerned with here is the part of his work on meter, which I'll admit is not completely separable from the rest. The biggest drawback to this tool is it doesn't have a public release. Right now, there's only a small demo of the phonology layer, though I'll come in a moment to something similar that does have a full web front end. Just as I also found, Fusi has detected the need for a number of successive layers of analysis to gradually build from a sequence of characters up to scansion. Here, phonology and scansion are the obvious steps. You first have to turn the letters into syllables, then determine the length of those syllables, and then scansion can flow from that with the imposition of a guiding metrical framework. He's right that an intervening syntax layer makes a difference, though. This syntactic step, which amounts to real natural language processing, is the toughest one, of course, especially since the word order of Greek and Latin poetry scrambles a lot of the cues by which NLP works. Of course, if Fusi can solve this, then his tool will be far superior to anything else out there. But on the other hand, if he can solve it, then there are a whole lot of bigger fish to fry. As I constructed my tool, I gambled that I wouldn't really need this. And while the next version of my program will have some open slots in the data for grammatical information, so far I have no plans to include a layer like this in a robust way. It's a lot of work, and the tool seems to be doing okay without it. If you assign Latin scansion homework to your students and they significantly outperform on the homework what they can manage in class, they may have discovered the Latin macronizer. This doesn't do search, but it does a pretty good job at scanning any line you throw at it. This is based largely on a very large dictionary. It really only has trouble when you give it a word that it doesn't know, or when the poet has invoked his poetic license to lengthen or shorten something contrary to usual practice. Still, it has real trouble less than 10% of the time. To me, this shows the power, but also the limitations of an approach that uses rules reinforced by a dictionary. Power, because Latin doesn't give you a lot of help in determining vowel quantity like Greek does. So the dictionary here really comes to the rescue. But limitations, because it doesn't deal well with edge cases. That's where my probabilistic model comes through. Even more helpful for the hypothetical desperate student is David Chamberlain's Greek and Latin meter site. This is the offspring of an abandoned algorithmic scanning project. As his about page states, after some attempts, he judged that reliable computerized scanning was impossible, and then began simply collecting scanning data, either doing it himself or taking it from other sources. There's an awful lot here, though it's notably slender in Greek drama, not that I have any right to complain. I really like the user interface here, and if you're trying to figure out a particularly tricky scansion, it's a great resource. But in terms of my key points today, that is automated digital scansion and search, it really doesn't do those things. I've saved Pedicerto for last because it's the tool most comparable to mine. This is also from Ca' Foscari, the University of Venice, where Daniele Fusi has been doing his project development. Like my search tool, this one is using automatic digital scanning, though a little more than 1% of the lines in the database are actually scanned by hand, so they haven't yet achieved a process that can address edge cases. More importantly, this is a database that does search, though it cannot, at least not in its open model, search for patterns across multiple successive lines. This is through Latin only, and their Latin dataset is about 40% larger than mine. Their search allows somewhat more complex criteria than mine does as well. One major difference between this tool and mine is the way it deals with word breaks, but again, I'm going to sideline that discussion for now. Finally, I should note that their user interface is quite nice. Of course, the criteria one might want to employ here can become complex, so the interface can become loaded with choices if that's what you want. But in general, it's quite attractive and easy to use. This is certainly one of the main drawbacks of my tool. I haven't had time to make it as attractive or as intuitive as I would like. I'd like to close by mentioning a few future directions for my tool. One thing I'd like to do is to expand what the word dictionaries do. At present, for instance, the dictionaries recognize that the letters S-O-L-U-M can represent either solum or solum, and so they just mark that first syllable as uncertain rather than long or short. They don't attempt to determine how often that particular orthography represents either option. Adding that in will help my probabilistic modeling. The dictionaries also don't have a definite idea of how often, say, the Greek word hoi is an enclitic and how often it's a proclitic. So I'm working on encoding more statistics and more grammatical labeling into those dictionaries. Among things that are quite helpful when it comes to the licensing of weird exceptions is knowing when a word is a proper noun or when it's foreign to the language in which it's written. I'm simultaneously working on building the dictionaries to include more words. This is a necessity because I'd also like the tool to work with more meters. The truth is that the version of the tool I use at home already scans and searches for a bewildering variety of meters that I haven't yet opened in the web version yet. There are two reasons I haven't done this. The first I've already mentioned is the difficulty with the interface. The second problem is that meters that have a true unkept syllable, like iambic, trochaic, and aeolic meters, require much more complete coverage by dictionaries in order to label those lone syllables properly. Even then, you'll never get 100% accuracy. I can easily imagine, for instance, a hendecasyllable that starts with either venimus or venimus, where even the best commentators would be divided. Or, for that matter, where the ambiguity is intentional in the first place, and even asking the poet wouldn't help. The expanded dictionaries should also simplify the procedure of accounting for appositives, those words that bind closely either before or after them. Once the tool knows the grammatical categories of the words around it, it's going to make a better guess about this. This isn't quite going as far as a true syntax layer like Daniele Fuzzi is developing, but I'm hoping that it's going to make the problem easier to solve. My guess is that there will still be some hand labeling of these words, even in the end. Finally, with the addition of more meters, I'm interested in adding more text. Greek drama, in particular, is a desideratum. I'm slowly working that in even now, though, again, as I've said, it's not going to matter to web users yet because I haven't yet provided the proper interface to query it. For now, though, the tool is, as far as I've tested, 100% accurate with fully automated scansion, and not bad at diagnosing word breaks either. I hope it will prove useful to my fellow hunters of obscure technical illusions like myself. Thank you.